Snail, can we start? Snail, are you there?
Yes, sir.
Okay. So shall we start?
Okay, so no problem.
Okay. Good morning, Ashish. Ashish, you are there?
Yeah, I'm there.
Okay, okay. Shall we start then?
Yes, we can go ahead.
Okay, okay. Snail, over to you now.
Yes, sir. Hello, everyone, and wish you all a very good morning. And today is day 3 of the international webinar series on Highrise Planning and Technology Perspective. I would like to thank you all for showing up in such great numbers for the live sessions. I welcome you all today for today's session on behalf of Appasaheb Binnai College of Architecture, Sangli, which is a significant institute of Shri Vasantrao Banduji Patil Trust running under Shivaji University, Kolhapur. We are a successful institute since more than 25 years now in rendering architecture courses for the bachelors in architecture, whose students stood first with a gold medal at the university level every single year. Our trust houses education from pre-primary school to degree courses in bachelor's in architecture, master's in general architecture, diploma in interior design, bachelor's in education, bachelor's in Ayurveda, and bachelor's in pharmacy. I would like to welcome and introduce you to the convener of this webinar series and our respected principal, Sir Architect Vijay Samrekar, who has been working at the elite designation from last 16 years. He holds a variety of achievements to his credit, like ME Structures, MArch, MBA with journalism, and so. He also has presentations in a number of different national and international papers till date. I welcome Architect Shantanu Jagtap sir, who is the coordinator of this webinar series and head of the Department of Masters in General Architecture at ABC Sangli, having tremendous experience as an academician and in architectural practice as well. I again welcome the co-coordinator of this webinar series, Engineer Praveen Pise sir, who is the structural consultant currently working as associate professor at ABCA Sangli since 20 years now, and also runs his own consultancy firms from 25 years. So participants, today is day 3 of our international webinar series on high-rise planning and technology perspective. And we have with us architect Ashish Karkar, who is currently working as senior lead architect at Khatib and Alami CEC Sharjah. Architect Ashish completed his bachelor's degree from IES College of Architecture, Bandra, Mumbai University, holding first class with honors in the year 2005. His work experience counts from 15 years now in countries like UAE, India, Canada, Singapore, China, Middle East and Levant countries, Kenya. And it covers varieties of sectors like urban design, residential, mixed use, retail, hospitality, education, etc. He has previously worked as a concept designer for concept design, design development and coordination, tender drawings, packaging, authority approvals, and design level value engineering. Ashish has previously worked as senior design architect at Space Matrix Design Consultants, Singapore, as a design architect at A0 Design Consultants, Spain Plus Eco Green Architects, UAE, as intermediate architect at Casian Architects Canada, UAE office, and junior architect at Arch Group International, UAE. So let us move ahead and listen to our architect Ashish. But before that, I would like to convey to all participants that we have the questions and answers session after the presentation is over. So if any questions that arise in your mind during the session, you are requested to type them in the chat box. And I request everyone to kindly mute your audio and video so that we all can have an unobstructed session. Now we proceed to commence today's session. But before that, we'll continue the session, and I welcome Ashish Karkar to take over and begin the session. Thank you very much. Over to you, Ashish.
Thanks a lot. And I really appreciate the number of participants that have come in, because it's a big number. and I hope I'll be able to do the justice to the time that I am allotted. So, right now, to begin with, on the topic of high rise, I would like to take this 1.5 hour time in the form of like 3 to 4 sessions. The first session, I would like to introduce the topic of high rise in overall format, in which case like I would like to touch base on how exactly this high rise design started getting explored, and how it developed from the ancient times all the way till now. Then I would take a couple of my projects to explain to you everything in practicality, because if I just explain things in the form of diagrams or in the form of simple words, I think it will not be that clear as compared to a visual content which I'll be able to share. And in that as well, I'll take you guys through urban design context first, so that people, I mean, all of you would understand exactly how high rise context from the urban design point of view is supposed to be understood. Moving on to a typical residential building, which is like a single use building going tall, to a mixed use building, wherein you will understand how different typologies of usages can be clubbed together in a typical high rise. And last but not the least, I would like to explain to you the latest trends in the high rise, and especially the trend of developing high rises from the point of view of the latest issues that have come up in the world, like the pandemic that's going on. Because one has to understand that architecture and urban design is a field that keeps exploring itself, and any and every new discovery or any and every new idea that comes in, or any and every new problem that the society starts facing, has to reflect immediately in the form of a design solution. I'm sure, like, once we start going through each and every aspect of high rise, you guys will understand what exactly I mean to say. Now let's begin with the term high rise. uh, Actually, it's very interesting to understand the concept of high rise from the point of view of a typical designer. I'm not sure how many of you are really aware of high rise in terms of uh, like the ancient design structures. But let me just, like, begin by saying that high rise. I hope all of you are able to see the slides.
Yes, yes.
Yeah. So as I just now said, like, I'll take you through these topics which are there in the index: the brief history, how to approach typical high-rise design, massing study versus building form, design influences, high-rise, a complex vertical mixed use, design for emergency, new age challenges, latest trends, projects. But to begin with, how exactly would you see a typical high-rise building? It's a very interesting question, because we have instances in the history wherein we have seen the high rises from the ancient civilizations in different forms. If you see the way it got developed over a period of time, if you see the ancient times, yes, we have seen the structures like the Great Pyramids of Giza, which are still standing. There were structures like the Tower of Babel in Mesopotamia, which are written in the literature, or in the Torah, which is like the Jew, ancient scriptures and all. Uh, these structures are really tall in their height, and that's the reason why you simply start calling it a high rise. That's the ancient definition: high rise, simple as that. But as it started moving towards the later civilizations, or towards the later trends that came in this particular topic, it's very interesting to see this place called Sana'a, which is in current Yemen, one of the countries which are like a part of the Middle East, and very, like, very near to the African side of it. There is this place called Shibam, where you'll find 7 to 11 story buildings entirely constructed out of mud bricks and adobe bricks. Here you will also find, a very sophisticated drainage system, a very sophisticated MEP, wherein the cross ventilation and everything is designed in those times. And this is about 1700 to 1800 years old development. So high rise was not something that was not known to the people. But the real problem in the high rises was the communication part or the commuting part. If you are at the ground level and if you want to really climb up, there is a certain limit up to which a human being can climb. I mean, beyond that, it's very difficult. And at the same time, when there is an emergency situation, there is also something called emergency evacuation, in which case, if you are really at a very high level and if you cannot run down all the way and just escape out, you'll simply die. So when these things started coming in picture in the minds of various architectural professionals and engineers, they started finding solutions to this problem, out of which in the early modern period, which is like say the later part of 19th century, certain technological advances took place, especially the prominent one being discovery of the elevators or the lifts as we call it, by which this whole issue of commuting between the lowest to the highest level started getting diluted. I mean, it became very easy for people to go from the ground level to any floor. And then the building started going taller. But if you notice, this trend of high rise, which started in Chicago and New York and those areas of America, initially started with also a thought process that a premium area like say New York City, where land prices started getting extravagant, could not afford to have a big building or a spread out building over a big land bank due to the economic concerns. So people started coming in with the idea of reducing the building footprint and going taller. So the same volume of people or same volume of function can easily be, brought together in a smaller footprint. So, you can really build a lot of those footprints in the overall city area, and you can create like a densely populated area, a densely populated town. And the main idea behind this was this whole what do you call the business opportunities that started coming in certain areas. Because unlike earlier times, as the civilization started progressing towards the modern era, you start seeing the emergence of places like city centers, or emergence of places like urban centers, or the business centers, or what we call as the concentrated zone in every city where a lot of businesses take place. Like it didn't remain as simple as the earlier times where you had like a marketplace and you had residential areas and then you had the palaces for the kings. So the whole idea of high rise started growing from that particular point, and then it also started flowing into Europe and all these modern cities, wherever the affordability was there and wherever business was able to thrive. And then came the new age where with the technology that started progressing from just a simple elevator connecting two levels to all the way like things like escalators and travelators and high speed elevators and so on and so forth. The buildings started going taller and taller. Now today, if you see the tallest building that is under construction right now in Saudi Arabia is almost 1,000-meter tall structure, 1 kilometer tall structure, which is a massive height. Even Burj Khalifa is like close to about 800 meters height, which is itself like a big feat, for the human engineering skills. Uh, Now all these things will give a very significant idea of how exactly a typical high rise or a typical tall tower gets constructed for the purpose of it. But at the same time, we have to understand that the purpose of any high rise is mainly to make sure that a large population or a large mix of businesses come together in one zone, which also later on started going in the zone of what you call the mixed use typology of buildings, wherein a typical high rise building was not just limited to having one function in the form of say only residences or only offices. It started having more and more stacks in the form of a hotel and a service department and an office and recreational areas and theaters and everything in one building mass itself. This increased the complexity of any high rise. Now, one also has to understand that it's not easy to just go tall, because when it comes to the structural part of it, you know, you cannot build a particular building that has a massive amount of structure, because the usable footprint is also one of the important factors to be understood when you are designing any building. And just imagine, like, if you have a tall building which is like, out of which, like, say 70% of the footprint is only structure, or 80% footprint is only structure, then the whole design itself is not feasible. So from all these point of views, like, things started shaping in the form of certain architectural standards or codes, or certain design practices, wherein the study of each and every footprint versus the height versus the urban factor versus the capacity of the street next to it to accommodate so many vehicles and all, started coming in picture in totality. So if I take all of this introduction in a nutshell, I can say that a typical high-rise design starts mainly from the urban design level. The city that is getting developed newly, or that is getting revamped for the new introduction of the various building typologies and all, should have its own inherent capacity, or should at least be developed to that extent, so that all these new tall buildings can be accommodated within that city. The biggest problem of a city like Bombay, or a city like some part of Delhi as well, but mainly for a city like Bombay and Hong Kong and so on and so forth, is the density of population versus the urban infrastructure that's available. And we always see this problem every now and then in these cities, where with thousands and thousands of vehicles start pouring in on streets in the morning time and the evening time. And all these high rises are actually the source of those vehicles, because all these high rises where you have 1,000, 2,000, 3,000 families staying together in that big apartment complex, or that big high rise, eventually has to come down on street. Eventually you have to come down, you have to connect with the urban fabric of the city. This is where the problem starts coming in if it is not planned well. So the first presentation that I want to show all of you is mainly on a new city that is supposed to get developed in the vicinity of Kuala Lumpur. I worked with a firm called Space Matrix, which collaborated with Gensler, and we did this presentation of a city next to Kuala Lumpur. And here, with the client, we already sort of sat together and formed a brief wherein high rise was unavoidable, because client wanted maximum density of population and business to happen in this particular city, so that it can start working more or less like a satellite city of the main Kuala Lumpur area. So if I take this particular project, which is called uh, are you all able to see the screen?
Yes, Ashish.
Yeah. So this city, which is called the NASA, is very next to the Kuala Lumpur, the main Kuala Lumpur city that exists today. And I'll just quickly tell you how exactly this whole city developed as a high-rise city. And you can see from the concept perspective that most of the buildings in the city are high-rise. They are mid to high-rise. And there is one icon tower which goes like really, really tall. Like, we anticipated that this tower can go up to 600-meter height, which means like it is like one of the tallest that can happen in not only Kuala Lumpur or not only Malaysia, but all over the world. Now, if you see the way the whole thing got studied, apart from the context of the city where it is getting developed, it's also going to have its own impact on the surrounding region, and it needs to have enough opportunity so that this concentration of people, this concentration of business and all the other activities is justified as well. I mean, if you just build a city with all these tall towers and there is no demand for any of those spaces, or people will not people will not like to come there and start staying in that particular area, then it's bound to fail. So the whole urban design of a typical high-rise city starts with what we call as the demand ratio analysis. We have to create demand as urban planners to make sure that the city's concept is going ahead with absolutely no issue. It keeps changing because what you have today as a design driver can become like a redundant factor maybe 3 or 4 years down the line. Things are constantly changing, and in modern era, the turnaround time or the period that is taken by the society to change itself from point A to point B is very less. So we have to be futuristic. We have to understand how exactly can we address the future issues by anticipating them at the beginning itself. And likewise, the urban fabric of the city needs to be developed and thought out. And at the same, sorry.
Yeah, please continue, Akash.
Sure. And at the same time, if you see, you have to study the surrounding zone of the city as well, from where the city is going to get linked. Now, all these factors which come in picture is basically addressing the fact that the central theme of the city is high rise, high population, high density of everything. So when you study all these factors from urban design point of view, it also goes into a zone where we may have to like address the fact that certain things that are existing right now are not enough or are not adequate, which comes in which comes with its own analysis of, say for example, increasing the connectivity by introducing new roads, increasing the road widths or increasing the number of lanes, increasing the number of airports or bus terminals or such infrastructural facilities. Then it also goes in the form of understanding the whole transit network that needs to cater to such a city. There are pedestrian networks, there are open spaces, there are utilities. A whole lot of things start coming in picture. Only and only then it is possible for us to analyze how such a densely populated urban zone can really become successful in future. If this is not done, what happens as a result is what we start seeing in a city like Bombay or city like Hong Kong, where there is a lot of chaos. And the chaos can be of any type. Like one of the major issues in Hong Kong is the amount of sunlight that practically reaches up till the ground. I mean, sometimes in some areas, your house itself is always in dark because it's always under the shade. There is no sunlight that can enter into your house because of the densely populated zones that have gotten constructed in Hong Kong, and it is unhealthy. On the other side, when you go to Bombay, you have a huge issue of traffic congestions because the roads are not wide enough, or the road widths are not studied in a proper manner in terms of its speed, in terms of its carriage capacity and all, to accommodate all this, the traffic that's going to come in with the high rises. So no high rise can be just thought out, isolated in a form of a in a form of a typical site in which you have to just go on constructing the building to a massive height. Even when the study of Burj Khalifa was made long back, when the whole area was conceptualized, it was not made in isolation. Like here in Dubai, things are planned as a city, and even after having a fairly I would say advanced infrastructure and road network, still there are issues of congestions because the number of vehicles keep increasing every now and then. So these things are extremely important to be thought out. And one small thing that I would like to share as a typical road planning idea that you guys can easily relate to is what exactly we try to do in such urban design studies is to define the widths of the corridors within which everything will start coming in the form of road and infrastructure. And it needs to be thought out in such a way that next 30 to 40 years of span is considered with the maximum peak capacity of vehicles, and accordingly with certain calculations that exist in the engineering branches and all, you understand what's the total width that you need, and then you define the plots after that particular width. So this width that you get, you start expanding from either ends, not from the center. So that what happens is, you start building the infrastructure going from either sides all the way to the center. And once it is fully developed, you know that the city is already over, the city's capacity is already reached. you are already, at that point where the city cannot take anymore, and now you have to find a satellite city, which is what happened in case of this particular presentation that I'm sharing. Kuala Lumpur is oversaturated, and that's the reason why Malaysian government wanted to develop a new city which is just next to Kuala Lumpur. I think this is what exactly happened in case of Chandigarh and Ambala in India as well. Although with the modern standards, Chandigarh is still not like very, very densely populated. But I think the standards that were set by Le Corbusier during his time are still maintained well. And that's the reason you see the quality in the city like Chandigarh. So it's a full urban level design that has to go in before you really touch the urban design, the architecture of a typical high rise. A plot needs to have high rise capacity. It needs to be allotted with certain uh, calculations from the urban design point of view, which will form the basis for any architect to develop that particular plot in the form of high rise. Because usually in the more developed cities or more organized countries, you get a site plan and an urban design booklet in which everything is very well defined. The number of towers that can come in that particular plot, the number of vehicles that should come in that particular plot, number of entry exits, heights, total number of floors, everything, including population at times, is well defined in this urban design booklet. This is the start of any high rise, and especially for the high rise, because high rise is a very, very complex subject, and it creates a massive impact on any city or any urban zone per se. So I'll just quickly run through this whole presentation. And if you can see here, you have all these components of a city, of an urban design level, where you have offices and hospitality components and residentials and so on and so forth. What is important here to understand is the footprint of this zone is maximized on its green footprint in such a way that the footprint of the building is minimized and footprint of the green is maximized. And then our concept was to also take the green footprint at the ground level all the way into the buildings as well, so that there is a lot of breathability. Because one of the major issues of a high rise or a densely populated high rise zone is this breathability factor, where everything is so urban that it becomes eventually a chaos. Everything is about hard paving and road and building and shades and shadows. You need to have breathing spaces, and they cannot be concentrated in only one zone. Like I was reading a very interesting article from one of the landscape designers, who said that in New York, when you see the Central Park and all these high rises around it, you feel that the ratio in terms of number is very beautiful, because you have open space versus built space ratio in a like fairly acceptable threshold. But according to him, distribution of the green zone amongst the city is equally important. So it's not only about the ratio factor, but also about the distribution factor that plays an important role for the success of any city, especially from the health point of view. So here, if you see in this particular design, you can see that a lot of things, a lot of buildings are designed here as tall high rises with spaces in between, which are given for this breathability purpose. So if you go quickly into the whole urban fabric and the whole idea of how we developed this, we took care of a lot of factors, such as the amenity and park spaces and sculpture park, tower podium, retail court. These are all the green spaces that can come in a particular city like this, especially with the high rises. Now, the thing that I was trying to explain to all of you, the Unity Tower, which is the tallest one in this particular city, this is a typical mixed use tower. And you can see from the diagram that you have 3 to 4 functions across the whole height of the tower. Now, any logical explanation of a mixed use is basically it just caters to but different type of people or different type of usages coming in one zone which caters to the success of that particular high rise, you know. Because if you imagine, like if you have offices, definitely office people will somehow cater to the food and beverages areas or to the business center areas or the retail areas in some or the other way. If you have residences, definitely they'll cater to things like gym, things like swimming pools and health clubs and all. So all of this once starts coming together in the form of a single stack, they start, you know, taking care of each other, and it becomes almost like a kind of ecosystem. And what we called it as a microcosm in one tower. The concept is very common nowadays, where you put everything in that one tall structure and start making it like interdependent. But the negative side of it also is you have to make sure that all these different things like hospitality component or a retail component or an office component somehow comes together seamlessly with their own issues, like you know, there are issues like privacy, wherein the office people wouldn't like their lift to be used by, say, residential people. So then you have to separate the number of lifts in that case. Say, for example, if you have a hotel component in the tower, they would rather like to occupy the tallest level so that, you know, the view is maximized and they get maximum benefit out of it. But the same can be applied to even an office tower. So you have to weigh which gives you more revenue and which should go higher in terms of the premium space. In places like Canada and all, you can even buy what you call the airspace, you know, so that your tower height remains maximum in that particular zone, and no other tower can come, like, you know, within the range of whatever, like 10 meters to 20 meters below your tower level. So all these things start coming together, and typically in a high rise, you know, these things form a lot of factors on the design brief. This is how you form the architectural brief, because you need to understand that you cannot just start from zero. You just cannot build, like, you know, 10,000 units in one building just like that. There needs to be, I mean, you have to have a study to it. Imagine a typical office tower where right from the ground floor all the way till the, say, whatever 100th floor, you only have offices. It will simply not work, because with the offices you need support facilities, you need amenities, you need business centers, you need things like retail at the lower level, you need food and food court areas. So all of this comes together. Because it is a high rise and because there is a huge concentration of people, it is almost unavoidable, as compared to typical low rises where 8 to 10 story office building with only a small retail and F&B at the ground level can easily work as a standalone building. But in case of high rise, it's not possible. So you can see here very easily that, you know, you need to create those spaces, you need to have those intermediate breathing spaces, you need to have those intermediate recreational zones, you need to make sure that the hospitality component doesn't interfere with the office component, which in turn doesn't interfere with the hotel component. So all these things together forms the complexity of a typical high-rise design. And this itself is the architectural brief. So you can imagine what is the impact of urban design, a typical urban design on a high rise. And it is much more in case of high rise, purely because of the complexity and purely because of the concentration of population, which I keep on reiterating, you know, whenever I'm talking of such a particular project. Any project that has massive density of population is always going to be challenging. And if you squeeze it in a smaller footprint and in a taller form, it's all the more challenging. It's simple as that. And as I go ahead, I'll also explain about the technical factors such as, you know, fire evacuation and things like that. But in general, this is how exactly a typical high rise starts. If you see here, you know, we had to study each and every component, like the commercial component, where exactly it should go, how exactly it should be designed in the most optimum manner. Then the retail component, which is below, can actually get catered by the population above, which means it already has a demand ratio. So you can imagine, like, you know, there are a few retails at the ground level which could be internal, which are not facing the street, but still they could be very well you know, catered by the population above, and they can really run well. If you take the same retail component in a smaller building, like say G+3 or G+4 story office building, then inevitably every retail tries to have at least a street frontage, because the amount of people that will come from the office tower itself or office building itself are very less. So any Starbucks or any coffee shop can easily work there. But that's not the only population that it should cater to. It needs population from outside as well, from the city as well. Here, the tower itself is a city. So you can imagine how complex this whole thing starts becoming and how easily all these things will start influencing architecture itself. And where it influences architecture is the diagrams that you see in the front. You need to have a strategy to cater to all these things. When you say maximization of view, avoid the cores in the periphery, take the whole periphery as a place from where everyone will get every the city view. This automatically brings you to a certain footprint where you know that okay, that's the core and that's the peripheral area, and that particular footprint around the core is going to cater to various components like residential, office component or commercial component or whatever you want to call it. That formed that's the way architecture evolves, out of the urban design context. Next thing, if you see the retail, the width of the footprint in a particular retail is determined by all these factors. Can you have internal and external retail? Can you have outward looking retails and inward looking retails? Can you have a core in such a location that anyone who comes from up down to that ground level has to pass through a certain retail zone before that person goes out of the building, so that you increase the retail footfall? All these things are forming automatically the architectural factors. So urban design for any high rise is extremely important. It cannot be ignored at all. Now, if you see the whole context of visitor experience, that's where we have to understand the human factor, because any hotel or any office or any business center needs to have this particular factor as a key design driver. So you can imagine, like, if you have a best view on, say, east side of the site, architecture will guide how to maximize on that view through the building form or through the amount of glazing that you provide towards that facade. But urban design will give you a driver to put those components in that particular direction. And that has to be followed for the success of this high rise. So it's very important to study the whole urban context from the urban design report of that particular zone. And then only it makes sense to go for a typical high rise architecture. Then comes a typical study of the environmental factors, wherein, one important thing that we have to understand is higher the concentration, more is the energy consumption. And as you go tall, a lot of energy is required to function that particular building for various technical aspects like MEP and so on and so forth. Which means your tower or your high rise is going to consume a lot of energy, and it's going to become like one of those places where, you know, uh, say for example, Burj Khalifa itself consumes energy that can cater to a typical town around it, which means such a huge concentration of energy consumption in one zone is a problem which needs to be solved from different ideas. This is where technology comes in picture, where the factor of sustainable energy becomes very important. If the building itself is used to generate energy and it subsidizes the amount of energy that will be otherwise used purely from the resources that are built to cater to it, it becomes more and more successful as a project. So there are various things that have started coming in now. You have wind energy, you have solar energy. It has become a very common factor now to use these two forms of energies, at least solar energy for sure, in most of these highly concentrated energy zones of high rises. But besides that, there are things like rainwater harvesting, because imagine the amount of water that will be consumed in this high rise. Imagine the amount of water that needs to go from the lowest level to the highest level and down. All of this is a massive ecosystem in itself. And the more it becomes self-sustainable, the better it becomes in an energy efficient high-rise center. And there are various design parameters that are used, or there are various design factors that are used to make sure that these things are achieved. uh, Especially in the place like the desert countries, especially like UAE and surrounding areas and all. Heat is one of the major factors where a lot of heat comes in a building, and here there is a trend of having glass facades and all, which is actually stupid, but I mean that's the way it goes. So imagine the amount of heat that is required to be cooled down through the air conditioning systems. This gave rise to the idea of having a district cooling system, where they most of the cities in Dubai that got developed after 2000 2001 have their own district cooling plant, where the entire city's air conditioning takes place. So you have a cooling plant where a lot of chilled water is generated. It gets circulated throughout the city, and within every building you have a energy station from where the cold water comes in and the hot water goes out. But eventually it's energy. You are consuming a lot of energy to make sure that all these things work seamlessly. So the more you are able to control this consumption of energy through the form of renewable or sustainable sources, the better you are able to cater to the environment. Otherwise, a typical high rise or a typical concentrated tall structure is an environmental disaster. That's, I mean, there is no brainer. I mean, it simply has no significance otherwise, and ever since high rise started becoming more of a status symbol than a necessity, because in New York it started more like a necessity, but later on it started becoming more like a status symbol, where every city wanted to have its own iconic tower, or every place wanted to have its own iconic structure and all. It started becoming like a problem slowly. So let's see, I mean, exactly how things go ahead from now on, because a lot of technological advances are happening. But in general, these are the issues that you have to understand from the urban design point of view. Now, I would share a project which is a typical mixed use project, which was developed again by my previous office called Space Matrix in Bombay itself. And this particular project is like a typical mixed use, where which is called the forest. Oh, I think somebody's scribbling on the screen. Okay. So now I'll take you to the architecture side of a typical high rise. And in a typical site analysis, the way it goes for all the buildings, you have to understand where exactly is the project located and how exactly the whole site analysis goes on in the form of the urban context, in the form of what exactly happens around and all. But what I come to now is the problems that you need to find out before you start developing a particular high-rise structure. So this is where we studied the connectivity of the particular plot. And of course, I mean, in Bombay, it's always very, very difficult to find a typical site where the road widths are enough, the number of lanes in the road are enough, there is enough space to expand number of lanes that need to get added for the service lanes and things like that. But we have to cater to this, and this particular plot was supposed to have high density in the form of urban design guidelines themselves. So we had to study all these things. So if you see here, typically the whole project was studied in the form of the components, which are hotel apartment, offices, residences, together with the podium below, which is mainly catering to the parking. And this whole thing was supposed to come within an area which was the earlier mill land. So you can understand, like, it's a typical mill land redevelopment project wherein we got a plot having a very awkward shape, and it had a typical problem of no major infrastructure around and no proper roads around and things like that. So if you study this whole thing in totality, you'll realize that we had to break the components in various parts and various zones, and then we had to make sure that they come together in such a way that the functionality of each and every element is not disturbed by the presence of the other. So I'll just quickly run you through uh, the whole program. The major part of the program was the residences. About, you can see, 84,000 square meter of residential area was something that we were supposed to cater to. Now, there is something called a massing study, where if you understand this whole thing in the form of, how tall and how wide it can spread, you'll understand exactly what is the guiding factor behind completing the whole form of the development. And here, if you see, when you when this particular thing was studied as a massive residential program of 84,000 square meters, we obviously knew that the tower is going to go very tall, and there was always a problem of designing a very very tall structure, a very very tall tower, because it becomes a problem. Imagine you have a tall tower in a place where you still have a capacity of developing, say, two or three smaller ones. I won't say smaller as in really low rise, but if you have a super high rise broken into three or four smaller high rises, it becomes easier for even a developer to phase the particular project. This is also another important factor that one has to understand, that if you create a single tower that goes 100-story tall, you have to finish it. You have to start and finish. There is no way. Imagine Burj Khalifa cannot be done in 3 or 4 phases. It will look horrible. It will look incomplete, if you just simply stop it at somewhere midway or somewhere at 3/4 height. So if you want to have that flexibility of phasing, which is a future proof planning, by the way, or if you want to make sure that you only cater to a certain demand of residential and remaining you transfer onto, say, a different component like, say, serviced apartment, that future factor has to be understood at the planning level. And this is where client and architect interaction also comes in picture. So going back to the design, if you see, we had this residential program of 90,000 of almost 84,000 square meters, which we wanted to understand in the form of how exactly it can be broken out. So here, if you see, we sort of developed the whole thing into a typical mass, and then we realized that if you break it into two zones, one zone being residential and the other zone being, say, a serviced apartment, it will start becoming more of a viable solution for the plot like this. And the lower levels can easily have things like retail and possibly offices and amenities and the parking. Because one has to understand that in Bombay, if you want to dig down 6 or 7 basements, it's not practical. You either get hard rock in places, or it's a coastal city. It's very very difficult to dewater in such a zone. And plus, when you don't have urban infrastructure around, it's a massive issue. So the idea is, in with all these urban design contexts, you have to go taller, you have to stack, you have to make sure that everything fits in that particular site in a way where you maximize on the site footprint, you utilize each and every nook and corner of the city, sorry, of the plot, and create a viable solution that can give flexibility and that can also give its own weightage to each and every program. So I'll just go to this particular footprint of residential to explain the technical aspect of a high rise. Now, typically they say that 24-meter plus height is considered as high rise by the US standards. It came from the history of firefighting. If a firefighting equipment or if a firefighting vehicle cannot have a ladder that can go taller than 24 meters, that means anything that's beyond 24 meters is high rise for the firefighting purpose. That's how roughly the definition started coming in for the high rise. Then it got broken into, say, a mid rise to high rise to super high rise to skyscraper to whatever. But what happens is, when you have a typical high rise design on an architectural table, you have to understand that it comes with a lot of factors, such as the vertical communication, which means the lifts come in picture. There is a standard scientific study that usually vertical transportation experts carry out, where a lot of factors are considered. For example, how much is the waiting time? How long would a typical lift take to reach from the ground level to the highest level? In mid-rise to low mid-rise zone, usually they say that from the lowest point, that's the ground level, to the highest point of, the highest floor, the lift should go within 1 minute time. That's like a very basic that we start with. But when you have a super high rise, or when you have like, real skyscrapers and all that are supposed to be designed, you cannot increase the lift speed to that extent. I mean, you cannot. It will create a health hazard. Imagine you are sitting inside a lift, or you're standing inside a lift that goes in the speed of a bullet train. It will not work. So then you have to break it, which is where the factor of refuges started coming in. Then the refuges got coupled up with other things like, a certain population of certain number of floors going to that particular area. The name refuge itself says that, if you are in that particular area and if you need to get rescued by the firefighters and people around, then you can easily ask them to, you can easily expect them to come there and then rescue you. Then came a factor of fire escape staircases. The capacities of fire escape staircases are also determined, and there is a code called NFPA, which is developed over a period of time, where the population density and the minimum width of the staircase, minimum width of the door, and all is calculated in a scientific manner. And there are tables that are given in that code by which you can easily calculate all these things yourself as architect. So all these things start coming in picture, in a typical high rise. Then there is a thing called pressurization, because if you have a staircase, you have to make sure that the smoke doesn't come in. In case of a fire, usually more than fire, smoke kills people. So if you are able to pressurize the staircase from within to make sure that smoke does not enter inside the staircase whenever people are opening the door and running inside, you are taking care of their life. That's catering to the fire safety of people who are going through the staircase. So all these things start coming in picture now as the peripheral components of a typical high-rise design. Then comes the design factor of structure. As I explained earlier, if you have a footprint where 70% of footprint is simply taken up by structure, then the high rise is not feasible at all. That means the footprint of the building is not good enough for a high rise until it comes to a point where you limit the amount of structure to 15 to 20% of the footprint, maximum say 25%. You cannot take that particular footprint as a feasible one. And it creates a lot of impact, by the way. This is where the structural designers who are experts in high rise and the architects who are experts would always say that in a typical high rise design, structure and architecture should start right from the day one. When the first line of that design is drawn on paper, they have to sit together, because if structural designers will not approve your footprint in the form of 25% maximum for their structural component, your high rise is not working. You have to make sure that you bring it down, you lower the height and you spread it across. So structure becomes very, very important. Then there are other factors like wind load, which will always apply on a typical high rise. Now, just imagine any tower that goes tall is like a vertical cantilever. We all know, like, when it comes to a particular cantilever, how exactly it works. So imagine a vertical cantilever that is, subjected to wind from all sides. So it will keep swaying. Now, to avoid this sway, or to make sure that this sway is within permissible limit, which will not hamper the structure, you have to have certain calculations, and that requires certain structural widths and certain structural framework. Then comes the earthquake factor, where if you have an earthquake of that particular seismic zone, the building should not fall down. After 9/11, even those safety factors started coming in, where if you say, for example, demolish 30 to 40% of the main columns or the main structure of the building, still the building should not collapse, is something that came in after 9/11 and all. So imagine the amount of structure that comes in a particular building like this. Now, when you take all these factors in place and link it with the architectural thought process, obviously there is a clash. A structural guy will come and tell you, I need a column of whatever, 1500 by 2000 mm. And an architect would simply say that that is too fat for me, that cannot come. Then there is a negotiation, there is a give and take. Then there are things like structural systems which come in place, wherein a composite structure where amount of steel is more than the conventional RCC can also play an important role in reducing the structural sizes. Sometimes for certain super high rises and all, you need to have structural transfer floors or structural binding floors, wherein like the structural beams are designed to make sure that the cantilever gets support at various heights to make sure that the structure is like sort of strong enough. Then there are factors like the core areas, because if you have a core which is strong enough, then the building is rigid enough to withstand all these wind factors and earthquake factors and things like that. The width of these cores or the size of these cores and all at times are massive, and usually in any high rise, a typical structure will always have a core and then the peripheral floor plate. Now, these floor plate shapes are also determined from structural point of view, because if these shapes are not able to withstand, or if they are not good enough to cater to these earthquake and wind factors, sometimes you have to change the shape. If you see, typically any high rise will have a broader base and it will keep tapering as it goes up. Any form, I mean, if you see Burj Khalifa, if you see the Freedom Tower, if you see any of these modern designs, usually it will have a broader base and it will keep stepping in, stepping in, and stepping in, because a typical pyramidal shape is most stable, as they say. But you imagine the shape is inward, and now you want to subject it to the wind factor or to the earthquake factor. Definitely, there will be a lot of problem. Even if just for the sake of form you want to do it, it may not become feasible from structural point of view. It may not become feasible from the floor plate efficiency point of view. So you have to change the shape again. All these things are so important at the concept stage itself, that even before you determine the building form, all this study has to go in, and it goes hand in hand. Then comes MEP factor as well at times, wherein like the amount of shafts that are required or the amount of openings that are required to cater to this particular high rise can also be massive. And the more number of voids you have in a floor plate, it becomes worse for the stability of structure, because you are literally puncturing through a floor plate. I mean, if I give you like a simple overview, any slab that you have, when gets punctured multiple points, it becomes unstable. Imagine like a net versus say a typical solid slab. You have to understand that these factors come in as very, very important factors for your design. Sometimes you have to understand that because of all of this together, your building shapes up in a certain manner. Unless you know that overall shape, or unless you know that overall footprint that is possible to be designed in that particular fashion, going all the way till whatever 100, 200, 300, 400 meters, whatever might be the height, you cannot start the architecture. So unlike many other designs which are more of mid to low rise scale, high rise cannot work in that typical way where you create the architecture, then go to structure, try to refine it, go to MEP, try to refine it, and eventually bring out a product. It has to go hand in hand together. And there are examples of concepts which were very beautiful when they were made purely from the architects, but when they went to these technical studies in the hands of engineers, those concepts simply failed. There are ample number of examples like these, and if you see the webinars, or if you cater to the webinars of all these structural designers from high-rise experts like Rambol and all, they will always show this as one of their slides, how a particular shape that was made by an architect in an isolated manner simply failed to cater to that a high-rise demand because of the structural issues. So here, if you see, the way it is designed is in the form of a plus shaped structure, wherein there are thick walls which are which you can see easily on in the center. There are cores in the center. The lift walls and all are all RCC, and there is one column per unit on the edge of it. The idea of this was to make sure that the unit gets absolutely no or least number of structural elements or columns, as they say. And as you go ahead and see I'll just show you the structural analysis of it quickly. This is the way it is done, where all these structural elements are taken together and the analysis shows whether it is stable or whether it still requires more reinforcement, or it still requires more width or whatever. So all these things together makes sure that the building, that particular high rise, is functioning quite well and is feasible as well from the point of view of everything, from the efficiency point of view as well. And there is one important factor that one has to understand. The idea of drywall technology that has started coming in last few years has really contributed well to the structural factor, because imagine you have brick walls or block walls on the slabs versus the dry walls. Dry walls are very lightweight, so it doesn't put its own weight on top of the slabs, which means for such a massive building, you are really reducing a lot of dead load coming onto each and every floor slab. This is one of the technologies that contributed to the reduction of certain structural sizes. Then there are things wherein there are technologies called tube structures, which was used also in Burj Khalifa, where you really you literally convert a lot of walls in the RCC walls and create like a structural framework wherein you don't have one big massive column going all the way up, but you have like series of small shear walls or small columns that go up. That makes sure that your structure is feasible from design point of view. Because imagine if you have a residential unit in which like you have a column that is massive, it will create a massive offset inside, and it will just like spoil the whole view of the unit, or it will just simply make the unit look very very awkward. So architecturally you have to challenge the technical team. Technically they are also bound to challenge the architectural team, and together it forms a typical high rise structure. Now if you see the overall development of this whole project, you can see that there is a residential, there are small sky villas at the podium level, and there is a hotel. Now the hotel is a typical mid-rise, and a residential is a typical high-rise, and then there is a big base at the bottom, which is mainly the parking and amenity areas and all. This whole thing together as a mixed use can work well because you have a retail. Again, the proportion of retail is determined by the market drivers, by the experts. This retail automatically gets a lot of footfall through the population in the hotel and the residential. Then you have these sky villas and all also. Now imagine if you want to have a small party of kids, rather than having it in your house, you can easily have it somewhere down in one of the restaurants, or maybe at the amenity level where you have like a multi-purpose hall. So if you start thinking on these lines, a typical concentration of population will automatically bring in a lot of factors that will make other components successful. If you have an amenity in the form of say a beautiful gym, which is also sort of taken up by uh, say Gold's Gym or equivalent kind of brands, it starts becoming also a commercial hub, because a lot of population from surrounding also can start coming in. It's a brand, but it's the inherent population of this particular site is also good enough. Imagine how much salability factor starts increasing the moment you start getting all these things together in the form of like that highly densely developed one site. So a mixed use high rise will always make sure that it is like a mini city in the city itself. And this is where architects come in picture as the real designers. Because just as a question, if I ask if I'm a client and if I ask an architect, and if tomorrow by the time this whole thing gets constructed, which will take maybe 4 years, 5 years, 6 years time, what if the demand of hotels is suddenly down because there is a lot of there are a lot of hotels that have come up in the surrounding? Then what you need to understand is, obviously as architect you need to provide for those buffer factors, which means your design should be flexible enough to make sure that instead of a hotel, the same thing can be converted to a hotel apartment, or you just demolish all the walls and just create that as an office floor plate. You just reduce the number of hotel rooms and increase the number of offices. So all these things will drive the architectural design. But eventually in a high rise, these things will always be there, unless you have something like Burj Khalifa, which from day one was conceptualized as a proper typical mixed use high rise, super high rise structure rather, which need not be phased, where most of the components were fixed and they went ahead exactly in the same manner. They are very, very rare projects. Other projects will definitely cater to a lot of changes or a lot of challenges as the project progress. Now imagine how exactly will you do that in the progress of in during the progress of the of the design, where say after 2 years of completing say a certain phase of design, suddenly the demand changes, or suddenly the component changes from say residential to hotel. Those things need to be anticipated earlier by the designers, and you have to design in that particular manner. There is a certain amount of flexibility that needs to go in every high rise or every densely populated design like this, and these factors exactly determine how good a designer is in terms of having that future vision. Most of the times these factors are not seen in the previous stages, because sometimes the client also is not really aware of what exactly is going to be the market, especially now with this pandemic of COVID-19. A lot of ventures have failed purely because of the massive population that they imagine to cater to. So you have to understand all these things, and you have to make your design flexible enough in that particular manner. Imagine a horizontal and a vertical flexibility together in a project for a typical mixed use. It's not a small thing to consider. It's a massive challenge for any designer. Now, one important factor that everyone has to understand for a typical high rise is the design of its facade. I'll go through a separate booklet of facade that we designed for the other project. But you know, technology has given us a lot of tools to design various types of facades. But you have to understand that for a typical high rise, even the facade is subjected to a lot of wind forces. So all these calculations from various structural experts and various facade experts come together, and that also impacts on the architecture. Because imagine you have a facade that is say 300 to 350 thick on top of the floor plate that you are designing. It is not easy. If you have balconies in a place in a building like Burj Khalifa at the highest level, it is impossible to have it open just like that with a simple railing. Imagine the amount of wind that will come at that level. In Burj Khalifa, apparently there is also a temperature difference between the ground level and the tallest level. All these factors are very, very, very important, and they cannot be ignored just like that. Sometimes your safety barricades at the tallest level go even taller. They can't be just 1.2 meters, because wind factor at times is very, very bad out there. Imagine like a strong gush of wind comes and you can simply get blown away. It's not easy. Sometimes if you design say a massive swimming pool at the topmost level for the view of it, like how you have in say Marina Bay Sands and all, but if that swimming pool is really uh, is catering to say the architecture, but structurally it's becoming a problem. Because imagine you have a huge tank with water filled in, which will create a lot of imbalance in the structure at times. You have to think about it as an architectural challenge. Not every time it can be done, wherein structural designers are becoming like slaves of architects and they just try to strive to realize architect's dream. Sometimes something needs to also be seen from the practical point of view. So this is the way the whole high rise works. And for the earthquake factors as well, new technologies have started coming in last few years, like where you have the cross bracings, where you have fire damp, where you have the earthquake resistant dampers, you have flexible footing designs and all. But all these things need to be known for uh, its own importance to a typical architect designer for a high rise. Unless these things are known, it's not possible to really venture into this particular field. It's a highly specialized field where not only experience but also knowledge plays a very, very important part. And for most of you, I think there is one small question that I want to ask you. I don't want to answer, or I don't want you guys to answer it right away. Just keep it in your mind and think about it. Okay. If at all you get a question from the client wherein he says that I want to expand my building in future vertically. Imagine how that thing can be thought about, because any horizontal expansion is very easy. You know that there is an existing building, you are simply adding another annexure to it. Imagine that happening vertically. That is one of the biggest challenges, and just think about it, how it will play in a typical high rise. That is something that you have to ponder onto as a designer, and keep thinking about it. A lot of solutions on high rise will become clearer whenever you find solutions to this particular question. This is how at least I learned my basics of high rise, wherein the first one that I started working on was a typical one where we had a clear floor plate and we knew how tall it will go. But then came another one where a 42-story high-rise building was supposed to go 55-story, where it was already designed from the structural and MEP point of view to cater to those 55 floors. But when the 42-story building is already occupied and now you are supposed to put something on top, it is not easy. Imagine how that whole thing will work. And it did work, by the way. It did happen. But just think about it. It's a question from my side. Now I'll take you guys through another presentation, which is a typical residential tower, which we designed in Bombay itself. Uh, Here I want to show you guys how exactly the parametric design plays a very important factor in aesthetics, but how this thing in case of high rise becomes a massive complex study. This was done by us in collaboration with a Dutch studio called UN Studio, and it is a very very beautiful project. But it's a typical Bombay project where there is a plot, there is a lot of FSI that got loaded onto this particular plot, and then eventually the massing said that this can go really really tall. It's actually stupid because you have a small footprint of the site and you can really go tall. The same issue that you have in Bombay, but that's the one that we have to cater to. Now, all these studies and all are straightforward. I mean, you know how it goes, right? Where you have a site, then you have to do the analysis of what is there in the vicinity, where is the best view, where is the least view, and all. So here, if you notice, because of the presence of a tall building just next to it across the road, which is also very narrow, we knew that one side of the building will not have any view, and the remaining three sides will have fairly okay view. So instead of having a typical design of core in the middle and floor plate around, here we had to go for core on one side and floor plate on three sides. This is where architecture is coming in picture to dictate to the structure that for the purpose of design, this is how we have to begin. And structure has to now work along these lines, and now we have to find a solution together. Because you have to understand, see, if you take a paper and if you put the weight in the center, paper gets better stability. If you want to blow away the paper, if you want to pull it off, it is little more difficult as compared to the weight being on one corner, because now the rest of the paper is very flexible. So the same thing applies here as well, where if you have a core on one side and rest of the sides are like free, then structurally these things will cater to the increase in the sizes of certain structural members, like the slab thicknesses or the cross beams or braces or things like that. Your core is on one side and rest of the thing is on other. So here that was one of the challenges, but luckily it was not like a super high rise. We were able to somehow manage this. A typical sketching workshop where we were trying to find out how the form and all can be developed, and various studies and all. But I think let's straight away go to the parametric side of it. You see here the facade was developed in a typical manner where a cube is distorted through certain geometrical permutations and combinations to form various floor plates. So you can imagine, like you just take say a paper, you take 2 points of the paper, you hold 2 points of the paper and just simply imagine those 2 points moving in a certain way as the floor plates go vertical. You'll get various shapes of floor plates, and dynamically when you see that in totality, you'll start seeing like sort of a very curvilinear, wavy pattern on the facade, which gives that impression of having a very fluid design. It's this very common thing. After the emergence of Zaha Hadid, who became the pioneer of such fluid designs and all, a lot of people did it, but before that it was also tried out in OMA and all, and now it's like a very common trend. But whatever happened, it needed to be seen in the form of a geometrical approach, because you can't just have a floor plate doing anything. You need to fix certain geometry to it, because that geometry will play important role in determining the sizes of the structural elements, divisions of the facade and things like that. This is the architectural part of it. Now imagine, as you go ahead and see the structural part, you see here there are two colors, one is red and one is green, which sort of shows two types of floor plates. There is a floor plate which is in outlined in green, and then there is a floor plate which is outlined in red, which changes its form. Why this is very important to understand is, this is imagination of an architect. Whether this will be really possible for a structural designer is very, very, very important to be understood. Imagine structural designer coming in and saying that this is not possible for me. It cannot stand. And he has his own analysis of various software that he uses. I have to simply give up this idea, because it's a high rise. If structurally it is not standing properly, there is no way I can go ahead for the architectural aesthetics of it. So as you see the way it goes up here, if you see this particular view, you can imagine how dynamic it is. But this whole thing had to get analyzed in that particular manner, and then came certain sketches for the facades, wherein we had to make sure that each and everything is seen in detail, where the decorative elements like pergolas around, the main structural elements like the slabs, the glass facade that is going to come on front of it, and all sort of comes together in the form of one cohesive solution. This is a high rise. So let's understand one thing, that when you have a typical high rise like this, it is not possible for you to think of it in isolation for just a typical plan or a typical elevation. Your plan and your elevation and the overall 3D with its facade, with its structure, with its MEP goes together, and it also has to fall in place in terms of environmental aspects. You have to also study its sun path and the wind load and the wind factor and view factor and everything. So I just want to show you guys the floor plan. You can imagine a typical floor plan of a building like this, where you have a massive core area. The reason of that is obviously because the core is off-centered, but still it was somehow like the floor plate was still flexible, because you're able to get enough units. But you can see the concentration of area is more in the core zone, where each and every wall of the lift, of the staircase, of everything is in the form of thick RCC. And then the peripheral area is only catered with the shear walls that are going tall. The reason being, if you try to increase the amount of structure in the units, it is going to make those units look all the more non-flexible, and all the more, I wouldn't call it ugly, but it's not very pleasant to see columns right within your units inside. So imagine the whole thing in terms of architecture plus structure. My architecture is defining my shape, the location of core, and the way the whole thing is imagined in the form of the floor plate. Structure is catering to it by saying, okay, I'm all right if you want to have core on one side, but the size of the core will increase. I need to have it really big. It needs to be really thick and massive. This is how high rise typically goes ahead, and then you start getting all these various floor plates. Now imagine, obviously, when you have a very dynamic floor plate, your column cannot just go dynamic. It cannot keep doing that. So when you have your column fixed and when your floor plate simply goes dynamic, you are talking of cantilevers. There are limits up to which you can do a cantilever, because if you have a massive 3 meter or 4 meter cantilever in a high rise across all these floors, obviously it's going to make sure that the slabs are thick as well. Now imagine like if you have like 400 500 mm thick slab, the amount of money that will be taken by such a structure will be massive. Then the financial feasibility will not work, because if you need to sell a unit for a certain price, its cost of construction should also be in a certain zone. If your cost of construction shoots up, your unit price also should equivalently shoot up. But if it's not possible to sell at that price, then you have to again go back to the drawing board and say, boss, maybe the concept is not working. There are so many factors. Market drivers will also ask you to take care of the financial side of it, and you cannot ignore it, because tomorrow the client can come back to you and say that you have given me a very inefficient design. Unless and until I price my unit at say 10 crore per unit kind of a price, I will not be able to gain my profits. What's the use of it? Who will pay 10 crores in a place where, say for example, this is Sivri. In Sivri, why would you pay 10 crore for a 1 BHK? You simply go, towards a town in Bombay and, get a better place or get a better unit in that zone. So you have to understand that all these things are coming together when you want to make a particular design successful, and especially in case of high rise, all the more. Now I'll get you guys through the facade design of the same project that I just shared, to just make you understand how you have to understand the detailing of facade for a typical high rise. We studied this in totality with the various sections that were drawn at various locations, depending on the way this particular facade is supposed to function. And you can see here, like, simple sketches, simple way of looking at it, where you have two types of floor plates, two types of peripheral profiles with certain with certain columns and beams and slabs coming in as a structural element, and outside of it is a decorative element like pergola. Now this is the reason why it's important for us to understand the structure of it. You see, when you take a structure and when you start putting your glass on top of it, imagine you cannot have a modular glass panel for the facade. Again, cost factor comes in picture. As many non-modular panels you introduce in a particular project, the cost will start going up, because you have to manufacture those panels separately. Then comes in picture the factor of the spacing of the columns. If you space the columns too close, it's going to be too much of structure. If you space the columns too wide, maybe the span is too big, so the column sizes will go up. So all these things, you have to really study in detail to understand how exactly you are able to find a proper solution to satisfy all the factors. And you can see here, those are the peripheral columns that we had, and then we had to really study each and every module between each and every column and understand what is the size of glass that should go there. More or less 1200 was working, but in a few locations wherever they were not working, we had to go for special profiles or special sizes. Because remember one thing, it's like a thumb rule in construction industry. If you have anything in the module of 1 foot 300 mm, usually you get that on the shelf. Like if you have a 600 mm size for a tile, you will always have 300 mm, 150 mm, 450 mm. But if you have 700 mm as a tile size, you have to either cut or you have to specially manufacture. Same thing goes for everything, So if you have a 1200 mm, okay, you will get that size of the glass. If you have 1100, still you get. But if you have, say, 1500 mm glass, it's heavy. It need to get specially manufactured. Imagine its installation on site. Imagine its transport on site. There are lots of things. They will definitely ask you to break it in 700, 700 or 750, 750. To me, if aesthetically 750 doesn't work because there are too many, vertical elements that will come in, which will block my view, I have to understand that I have to find a solution architecturally in this case. I cannot simply say that because my architecture wants 1500 mm size of glass, you guys do it. Sometimes it works, sometimes it doesn't work. In a place like Dubai, where up till now there was no problem of money and all, yes, people used to go for such extravagant solutions. But in most of the places, they don't go for it. And it's actually more logical to not go for it, because it doesn't make sense to force something which is unnatural for that particular design. Now, all these things that we designed in the form of the facade were detailed out to make sure that each and every factor, each and every element of the facade, the verticals, the horizontals, the peripherals, the decoratives, everything sort of gets sorted out properly. So that's the way a particular high rise in totality works. Now, this is a thing which I wanted to explain to everybody as one of the major challenges in high rise. You build something that is 600, 700-meter tall. How will you maintain it? Internally, it's easy because they're able to access everything. How about external? There are systems available by which you create some of the massive engineering systems for the facade, which are roof installed, which are facade installed, and then you do everything. But is it only a facade cleaning system? It is not. It is facade access system, what we call as FAS. Why access system? Imagine on a building that is 500-meter tall, at somewhere around 300-meter height, 3 or 4 glass panels need to get replaced. Something happens. You have to maintain it from outside where there is a leakage of air for some reason. You have to just replace the light that is there in those vertical fins at some location. How will you do that? You cannot just hang a man with a rope from the top. It is not possible. You have to have a system. There are cradles. There are systems by which you install the machinery or the mechanism on top of the roof, and you make sure that the cradles come down all the way on the facade, which is safety wise advisable, which is very convenient in the form of working out on that facade. Because imagine you have a glass panel that is weighing really, really heavy, and you want to replace the existing one with the new one. It will not require only 2 or 3 people. It may require much bigger workforce. At times you have to install certain things on the facade, because you have to understand that when you create an iconic tower or when you create an iconic high rise, it is not just serving its program. It also has to become the icon of the city. So nowadays, marketing gimmicks play a very important role. Every now and then you'll see on social media, a photograph of Burj Khalifa showing the flag of India on the Independence Day of India, or flag of some other country on that particular country's Independence Day and all. What is it? This is marketing. This is giving those attractions in the minds of people, which will boost tourism, which will bring in people over there. There are laser shows that are taken place. The whole facade of Burj Khalifa is used like a massive LED panel, wherein a lot of things are at times displayed. At times they also display certain messages during the holy month of Ramadan and all. You'll see those Ramadan messages and all also. This eventually is what? These are eventually lights, LED lights. If those LED lights are there on the facade, you have to cater to them. You have to replace them. You have to make sure that they are working properly. At times you have to maybe just check all of those in the various intervals and all. So you need to access it. It's simple as that. If at all you have an emergency situation where there is a fire at 105th floor in a 150-story building, what will you do? You can only bring people to a certain refuge area, or you can just make sure that by some means you go from outside and try to douse out the fire, because it's not very easy to always cater to the fire situation in a tall high rise. Imagine the firefighters coming in, even if they take the lift that is dedicated for the firefighters to go up to that level, take the hose reel and just try to douse the fire and all. It's not very easy to do it, because the time factor plays a very important role. By the that's why when it comes to fire in these massive high rises, it's always a big chaos. Now there are technologies that are available where you'll see the firefighters literally, sort of flying up. Like here in Dubai, we jokingly call them Supermen, because they actually have an equipment on which they stand and they go up. And from the facade, from outside, they can try to, just spray the chemicals and try to douse out the fire. But imagine that is not very easy, because you are eventually talking of what, like, the height of 300, 400, 500 meters. Imagine anybody trying to go to that level in open and trying to fight with the fire and smoke, the massive smoke that comes in. Then also comes in another factor where if there is a fire at that particular level of the building, when the glass pieces break and fall down, what is going to happen to people below? It is it's but obvious that even if the glass piece is not pointed, if it falls from that level, even one glass piece is enough for the person to die. It can simply, break your skull. It's very simple. So all these things have to get catered through engineering solutions. It's not very easy to find a foolproof engineering solution that will have 100% solution of every emergency aspect that may happen in that particular building. But technology is advancing. It is making things available for people. Now a few years back, when I was working for all these Bombay structures, I came across a system where they said that we are going to have a chute system where you simply go down from one chute, you go to the other chute, you go down, and likewise you simply escape from the building. Now, how tall can this chute system be is a question. Imagine if you have disabled people in the tower and there is a fire and suddenly you have to evacuate. Where would these disabled people go? So in America or in Canada and all, they have a system where the fire escape staircase gets its own small module. It's like a small enclosure where 2 to 3 people on wheelchair can simply be kept until the firefighters come and rescue them. Are we really doing that in our cities in the form of update of the city codes? Is also a question that we need to ask ourselves, because all these factors form the success of the high rise. More often than not, in such high rise, in all these high rises and all, emergency situations have created disasters. Very often you'll see, the death rate of people in such cases is obviously high. Here in Dubai, earlier they had a code by which the aluminum cladding was supposed to be tested against fire only on its surface, but the internal sandwich panel system that they had, if you take a section through the aluminum cladding, the sandwich panel system that they created had the infill which was combustible. So whenever you have the trims for aluminum cladding, those edges were getting exposed. So in last 2 or 3 years, they have done these updates in the code by which aluminum cladding in itself, as a section and as a bent section and as a totality, needs to go through the fire testing before it can be installed on the facade. But till this code came in picture, you see the fire that took place on the Address Hotel next to Burj Khalifa. You see the fire that took place in Sharjah a few days back. The whole facade got burnt, and the entire building was simply like it had to get evacuated, and the building is right now standing as a tall mass of black color. Because the amount of damage that happens to a typical high rise with just a small fire in one corner can also be really, really massive. Like in Singapore, you have codes where you break the whole facade as well in smaller fire zones. So you have like fire breaks in the cladding itself. So if there is a cladding in one zone, it cannot just simply spread out everywhere. There are codes in America by which certain materials are not allowed to be installed on high-rise facades and all for their combustible factors and all. But this is still progressing. This is evolving. When you know the problem, you know that you have to find a solution, then you find it, then you introduce that in a code. But very often it happens that a complex structure, a complex project like this, like a typical high rise, can never have everything spick and span in its place from the day it gets designed till the day it is built and for another whatever 50 to 100 years. Always it's going to evolve. So for us as designers, whenever we are seeing any high rise, it's really, really important for us to understand all these codes, and at times it makes more sense to follow the more logical code, despite it not being applicable in your zone, like what we tried to do in some of the projects that we made in Mumbai, where we insisted on certain things despite them not being a compulsion from the local fire code, because it's more logical. And as a designer, it is our responsibility to make sure that somehow, like, we convince the client for that particular application of code. Uh, then if you consider say NFPA, there are certain calculations that are written about the widths of the roads or the open spaces around a typical high rise. Now the reason of that is simple. Whenever a fire tender comes next to a building to take care of the fire situation, imagine you have a very, very narrow road, and you have to really cater to the building that has a fire at 80th floor. It is not going to be possible. By the time the firefighters reach there, by the time they park their vehicle, they sort of raise the ladder, they do everything, maybe the fire has already taken place, and maybe there is a lot of damage that has already happened. So high rise also is supposed to come in place with respect to its surrounding urban infrastructure. This and that's why, like, I heard a very beautiful sentence from one of my friends, who kept saying that no city can be more beautiful than its code. The code of practice for engineering and architectural and urban design things that we always cater to. If they are strong enough, if there are proper thoughts given to each and every of those codes, and if people have really given attention to it, then the city will be definitely beautiful. Like the one that I shared with you, the Kuala Lumpur city, we were also asked to sort of follow certain international standards, which, despite not being in practice in Malaysia, are supposed to be more logical. So in that case, we know that the city is becoming more beautiful. City is becoming more safe. It's becoming more breathable, buildable, habitable. But that is a responsibility of people like us, urban designers, planners, architects, and all. But otherwise, for certain things like a typical high rise, where you're talking of like a massive population in a small footprint across the number of floors above, it is definitely not easy. So I'll just take like another 2 minutes to conclude this whole thing, by which I say that no high rise in today's age is uh, that easily buildable if you don't consider the structural and the MEP and the technical side of it in totality. Today, technology is advancing. You are able to get a lot of new introduction of various materials or various engineering solutions and all, to make sure that it is as lightweight as possible. You are able to even now reach 1 kilometer tall distance through the tower that is coming in Saudi Arabia. It may go 2 kilometers, 3 kilometers, you never know. But eventually, it's all about how much the city needs it, how much is the requirement of that particular urban zone, and whether it is really necessary. If you concentrate a huge population in one small zone, it gives you a massive responsibility as a designer. It's not very easy to do it. And if you think from that perspective, if you have that conscious in your mind that you are responsible for the lives of so many people, I'm sure, like, your designs in future, wherever you do it, will obviously have its own human factor attached to it. So I think I'll just conclude right now on the fact on this presentation. And I mean, if at all there are any questions, then let's go for it.
Yes. Thank you, Ashish. Thank you for this wonderful session. We now proceed to the question and answer session. So if you have any questions, please text in the chat box. We have one question, Ashish.
Mhm.
How much do you recommend the high-rise building in seismic areas, and how to minimize the risks?
Actually, all these things are engineering solutions, because you have high-rise buildings in Mexico, which is a very massive seismic activity zone. actually it's not about what kind of seismic zone that particular area is. It's about engineering solutions to it. And then, as I said, you have to weigh it against the floor plate efficiency and understand how tall you can go. Because there are engineering solutions available nowadays for like almost every disaster.
Okay. Um, how do you use or how do you reuse a refuge area?
Actually, it's a very typical concept in certain zones. Refuge areas are not supposed to be used for anything else than the refuge itself. I mean, you have to understand that, right? So, for the life of people, it needs to be only and only seen as a refuge, but that can be used as a green area, as a green terrace area, which will add a little bit of breathability within that, densely populated high rise, which is what most of the people nowadays try to do, because it becomes like a nice garden, at least a visual amenity and maybe a functional amenity as well at times.
Okay, there is one more question. What softwares are used for high-rise building design?
You can do it in AutoCAD. There is no problem. Software is just a tool. Actually, nowadays, all these parametric software and Revit and AutoCAD, all these things are good enough. The main thing is about the structural design software, because most of the times the city code will, like at least in US and in UAE and all, they have specific software written for the structural design of it, wherein the ETABs and all these things are supposed to be given in a certain format only, and then the earthquake factors and all are supposed to be catered in those models. But apart from that, for design, any software you use is not a problem.
Okay. There's one more. What kind of materials can be considered dangerous in facade construction?
Any material that can catch and spread fire. So nowadays, if you see all the materials that you use for the facade, because as I said just now, if you consider aluminum itself as a metal is not combustible. But if you are putting an infill within the two sheets of aluminum, which is combustible, eventually it is going to spread the fire. Or if you have the silicon joints between two glass panels or two aluminum panels, which are not fireproofed or fire tested or fire resistant, it is going to help the fire spread. So anything that is not allowing the spread of fire is what is supposed to be used for the facade.
Okay, next one. Do you think Navi Mumbai as a satellite city to Mumbai has succeeded or not?
How many of you know what was the original idea of Navi Mumbai? I think if you know the original idea of Navi Mumbai, no answer should be given to this question. You yourself will say it is not successful.
It was just designed to create a new urban center,
Yeah.
divide the population, crowd and all.
Charles Correa wanted to shift even the Mantralaya and all the secretariat offices and government offices to Navi Mumbai.
Exactly.
Because all the population that goes to the South Mumbai area from all across the suburbs and all was supposed to get diverted in that direction, which didn't happen. So you can imagine how successful it is.
Okay, shall we move towards the next question?
Yeah,
What will be the deflection in gust?
it's a structural question actually. I'll not be able to give a proper answer to this.
Very technical.
It's a structural design question.
Okay, we have two more questions. Are there any standards for designing of the core in high rise that can determine the shape of the structure?
No, shape of the structure, no. But see, you have to understand that there is an FPA, which will give you the sizes of the staircase widths and such things, number of staircases and all. Then you have the standards of lifts, because based on the vertical transportation analysis, you know what size of lift is required. So all these things will at least give you the sizes of those elements which get encompassed within the structure. So you know what is the size of that entire core in totality. And then when the structural designers apply their own codes and give you the size of each and every structural element, you know how big the core goes.
Okay. Next question is, can you could you please throw a light upon bioclimatic structures?
Well, actually, it's a new technology that started coming in last few years from the sustainability point of view. But you have to understand that there are certain limitations to such things always, because uh, when you are consuming massive energy anyways, because of the sheer concentration of population that you have in a high rise, you cannot compensate, say, 60, 70, 80% of its energy consumption through these sustainable factors. So you can only try to make sure that a certain percentage of energy consumption is subsidized through bioclimatic facades and all. Nowadays you get, like, high performance glasses which themselves are inbuilt with solar panels and all, which generate their own energy. So nowadays those experiments have started happening in some of the European cities, where every flat will have, let's say, 20% of its energy consumed out of that particular resource. So the facade itself will generate, say, 20% of electricity for your flat and all. But it is still limited, because not every time you'll have the same quality of sunlight, not every time you'll have the same quality of air. Nowadays they have started coming in with the bacteria infused facades as well, which create oxygen and try to sort of purify air inside the units and all. But it's not possible to be done to that extent, where suddenly inside your apartment you have like massive amount of oxygen getting generated by the bacteria. It's not possible. I mean, you cannot challenge nature. Eventually you have to go back to nature to get what you need.
Okay. Next question is, at students level, how could one develop the concept of parametric architecture? So initially, which software helps in parametric architecture?
See, parametric actually comes through software only. You cannot sketch it. You can just sketch the idea, but the permutations and combinations usually happen in software. At student level, you can explore forms through all your parametric design tools that you have. Like, there is Grasshopper, you have plugins in the Revit itself, you have Maya, which used to get used very often in old days, but nowadays, like, usually people go for Grasshopper and things like that. uh, the thing is, parametric is not like people have this big aura of parametric in their mind, that, my goodness, there is something beautiful, what Zahadid does is amazing and all. It's about mathematics. You have certain XYZ factors in the software, where you just put in numbers and it will give you those combinations in the form of a 3D mass. So it's all about exploring the software, and it's all about you understanding how you are supposed to control those factors. It's purely about massing, because you have a parametric plugins for SketchUp as well nowadays, where you just put that plugin and you create like a beautiful wavy looking pattern, or you create those patterns of solids and voids for the facade paneling and all. It's purely about how well you practice those software. It's a tool.
Okay. Next is, what steps are taken to provide safety to the high-rise buildings?
Actually, it's a massive subject in itself, the safety and security of a high rise, because it all starts from, first of all, the fire protection. Because for a high rise, fire protection comes as one of the most important factors. There are things like fall protection that you have to understand, wherein the height of the railings and the height of the facade barriers and all play a very important role as you go taller. uh, but more or less, these things are always there in the codes, like NFPA and all. You know what exactly you need to apply, and the code will tell you that this is the minimum area that you need to have for the refuge, or this is the minimum width of the staircase that you need to have. This is the minimum or maximum uh, fire rating that you need to have for a door or for whatever. Once you do that, the safety is already taken care of. You don't have to do anything else, because experts have already studied it and added that to the code.
Okay. Now we proceed to the last question of this session. What precautions can be taken in regards to foundations in designing a high-rise structure, if at all it is located between two already existing high rises on either sides?
Actually, it's a very interesting study for a structural designer and even for architects at times. Usually what happens is there is a study that comes in picture wherein the existing structures on either sides, in terms of their strength, in terms of their vertical and horizontal alignments and all, are studied, and against that the way your structure is supposed to sit in is also sort of studied in the software. And what makes important here as a factor is whether your building or your foundation is not destabilizing the neighboring ones. And it's a massive engineering study that comes in. And usually, like in Dubai and all, you'll see very often that foundation of one high rise is literally touching the foundation of the other. There is nothing wrong in that, but it's all about the structural study. And what plays important role here is the waterproofing quality. If your waterproofing quality of structure is not good enough, then in future, if water starts seeping in, it's going to be a disaster. So that is one factor that normally all the structural designers look into, and the other things that they do in the software. But eventually it's engineering, because as architects, for us there is nothing. We have to simply take from engineering the solution that they have provided in the form of the peripheral wall that is required for the whole foundation or the whole basement, and then inside area which we are free to design our things into is what we have to play in as architects. It's an engineering part, not architecture.
Okay. Thank you very much, Ashish, for all the answers. And having you here was a wonderful session. And it was a wonderful presentation and very important part to be covered and highlighted with respect to high-rise planning and technology perspective. And its significant study by laying out wonderful examples of the projects you have worked upon. It was a very good session, and I believe that all our participants too have gained enough benefit from this. Now I request our coordinator, Architect Shantanu Jagtap sir, to take over. Over to you, sir.
Thank you so much, Ashish, for the wonderful presentation. Because last 3 days we are exploring all hidden explorations of different perspective of high-rise buildings. And thank you so much for today for enlightening us such a different perspective of high-rise building. And you are covering all the aspects like the impact of urban design and its fabric to the high-rise buildings. Then how an architecture evolves around this urban design fabric, and then you are doing you are giving you all enlightened contents about the how and different approach like a parametric approach in a new concept of architectural presentations, as well as in the logistic designing approach of it during the structural and other aspects. So thank you so much, Ashish, for giving all the logistic and fundamentals approach in this webinar series. And now I am request again to you, Snehal, to go for further concluding proceedings. Thank you so much.
Sure, sir. So before we move towards concluding today's session, I would like to inform all the participants that you shall have the feedback link very soon. And now I would like you all to introduce to the convener of this webinar series on high-rise planning and technology perspective, and also the principal of Appasaheb Binay College of Architecture, Sangli, Architect Vijay Samrekar sir, who has been working at the designation for more than 16 years now. He holds a variety of achievements to his credits like ME Structures, MArch, MBA with journalism, and so on. He has presentations in number of different national and international papers till date. Our respected principal sir has successfully provided some added courses besides architecture, like the State Board Diploma of Interior Design and Decorations, Masters in Architecture in the General section under Shivaji University, the NPTEL distance learning courses in collaboration with the Indian Institute of Technology. So now I request Architect Vijay Samrekar sir to take over and express a few words. Thank you so much.
Thank you, Snehal. Good afternoon, everybody from India, and good evening from out of India. I am Architect Vijay Samrekar, Principal of Appasaheb Binay College of Architecture. Welcomes all of you in the concluding session of this international webinar, High-Rise Planning and Technology Perspective from last 2 days. In India, there is a scarcity of land for urban horizontal development. So it is the real need of tomorrow to go for high-rise structures or high-rise neighborhoods. The technology of the high-rise structures is very difficult from India, regular conventional, and it is different from regular conventional structure. In USA and UAE, the total latest construction technology for high-rise structures come very soon. Hence, we decided to take the experts from outside India for this webinar. We got very eminent speakers. In the first day, architect Viraj Sarode, senior project architect from USA, highlights on high-rise facades, types of facades, material used for facades, and the international code about high-rise, about the code publication, proposal, and types. His presentation is very informative for everyone. So I am very much thankful to him on behalf of our college. The next day, architect Kashmira Sarode from USA is senior architect, gives the highlights on technology reshaping the AEC, means architecture, engineering, and construction industry. She explains about journey from T square to 6 dBIM, means building information model. Her information is very innovative, so I am very much thankful to her from the institute. Now today's session is conducted by architect Ashish Kelkar, senior project architect from Dubai, UAE. He has high-rise design and need for design, planning, elevation, floor of the floor plates, shapes, and with respect earthquake and very nice case studies. His presentation is very systematic and informative to everyone. So I am thankful to him from my institute. I am thankful to all the speakers because there is a difference of clock time from India and other countries, but they agree to go with our Indian time. So I am very much thankful to him for their positive and holistic approach. Now, I am also thankful to Engineer Praveen Pise as a coordinator of this event. And especially I am thankful to Architect SP Jagtap. He's a coordinator and for his very hard work for this success for this event. And then I am also thankful to Architect Snehal for her sweet information of the introduction of the speakers and their vote of thanks. And I am also glad to say here that Architect Kashmira Shah Sarodi is a past student of our college, Upper Secondary College of Architecture. So I am very proud of her. I am also thankful to all the participants with very large number from almost all parts of India as well as from abroad for showing interest in this topic. I am also thankful to our parent trust chairman, Sri Samir Birnali, and our board of trustees for giving free hand for arranging such kind of webinars. And I am also thankful to our all teaching as well as non-teaching staff members of the college for helping directly or indirectly for this webinar. I am especially thankful to Vikram, Akash, Shinde, Yuvraj for their technical support. Now I am after this concluding session, we will give you a link, feedback link. So fill up this feedback link along with the quiz. You will get the e-certification, and this link will be closed tomorrow 11 a.m. Now I am declare that this international webinar is completed. Stay at home and stay safe. Thank you.
I just want to say that anyone if needs to approach me for any information, just you can approach me on my name ashishkalkar@gmail.com anytime. I'll be more than happy to help if anyone wants to know any other information regarding Highrise. Anytime, I mean, I'm approachable anytime for any help required.
Thank you, Ashish.